Okay, I am live with 52 weeks of AWS, and I'm going to be talking about planning for disaster today. And I'm almost done with the AWS Solutions Architect training material. Next week, I'm going to cover really getting ready for the exam. So we're in the final stretches here. And thanks for everybody that's been listening to the podcast. There's thousands of downloads here. I think pretty soon I'll also be able to give you access to more study resources. So I think I mentioned this before, but I have at noagift.com a list of different resources that I'm creating for people, including office hours every Tuesday at 5 p.m. I also have a Discord server. I'll probably be launching a course very soon as well that helps you prepare for the solutions architect professional. If you have access to LinkedIn, I think many people that are watching this are on LinkedIn. You can also prepare with the AWS Solutions Architect professional course that I've got there on LinkedIn. All right. So with all of that out of the way, let's start with the material here. So I'm going to go ahead and share my screen. And let's go ahead and do that. Here we go. So I've got the official material up, planning for disaster. So one of the things I think that is interesting about disaster recovery, and I've unfortunately had a lot of experience with this, is that you don't expect it to happen, but as the CTO of AWS says, everything fails all the time, and you have to plan for disaster, or else a disaster will occur when you least expect it, and it could be devastating to your business. And there's a few different ways to think about this. You have a small scale event, you have a large scale event, and you have a colossal or existential threat. Existential means that basically you're having widespread outages that you could cause the end of your business. So small scale is basically like a server stopped. Maybe a large scale event would be multiple resources are affected across an availability zone within a region. And then a colossal scale would be that, basically your database is deleted, right? That would be a colossal event. Unfortunately, I've had all those events happen to me in my life. So what are the things you can do to avoid the disaster and plan for it? One of them is to design your architecture so that it's highly available. Make sure that you're minimizing how often your applications and data become unavailable. So if you're not designing your system to be highly available, it won't be highly available. This is an easy one. So can it withstand problems that occur, like a server going down? Backup. So making sure that your data is safe in case of a disaster. This is one that's kind of easy to maybe think you're doing correctly, but if you don't have a game day scenario where you're able to restore periodically, you don't really have a backup. You have what you think is a backup, and that's even worse than no backup. And so if you don't do regular restores, you're just asking for trouble. Disaster recovery, or DR, is the ability to recover your data and get your application back online after a disaster. So this is another scenario that people don't talk about, but if it takes potentially 6 weeks to restore your data from backup, it may be possible that your company will not exist anymore. So you also need to figure out how much time you have to restore your data. So what are some of the things that AWS recommends here in terms of their well-architected framework design principles? One is there's an operational excellence pillar, and this would be anticipating failure, refining your operational procedures frequently, basically making sure that you are evolving your workload so your procedures are able to match it. The reliability pillar is describing the importance of designing systems and making sure that you have test recovery procedures. So if one of your systems fails, for example, you're able to validate the recovery procedure. You can use automation to simulate different failures, even recreate scenarios that you've had in the past, and also make sure that you're watching out for brittle things that that once you do a restoration, it requires people. Another one is this concept of automatically recovering from failure. And if you monitor your system for key performance, you can trigger automation when something is breached. So these KPIs could be business value oriented or even technical aspects. So latency would be a good one. Like if you're getting enough latency, maybe you actually tell that instance to go away and you add maybe 2 more instances. That would be maybe a good example of an issue that you could handle automatically. So recovery point objective is the concept of the maximum acceptable amount of data loss measured in time. How often must your data be backed up? So an example would be a business could recover, let's say, from losing at most 8 hours of data. That would be the last backup. And then in between the time when the disaster strikes, you only lost 8 hours of data, right? So that could be your RPO. Now, if you have only backed up maybe once a month and you can only afford 8 hours, you have a gap. A recovery time objective is the maximum acceptable amount of time after disaster strikes that a business process can remain out of commission. So basically, how quickly do you have to recover your data and rebuild your application? So maybe if it's something to do with medical records, maybe the application could only be unavailable for a maximum of 1 hour. And so now you have a different situation, which is you have to make sure your system is designed so that it can be fully restored in, let's say, under an hour. So how would you do this? Well, you could actually design for disaster recovery, you plan it out, be intentional about where the data is stored and where the applications run. And this is not easy, right? It requires real thought, architectural skill. Some of the things to consider would be the storage, the compute, the networking, the database, the deployment orchestration. The most robust disaster recovery plan spans more than one region. And it's also important to keep in mind that although it's unlikely for a region to be unavailable, it's possible. So could you design your AWS environment so that it's multi-region, right? And this would be potentially something to consider, is how easy would it be in a huge disaster to potentially spin up your entire stack in a different region geographically if there was an outage in one part of the world. How about storage and backup building blocks? So it's important to know there's different kinds of storage options. And in particular, there's block storage, which is Amazon EBS or EC2 instance storage. These are storage that are attached to one instance. And with EBS in particular, it has the ability to be snapshotted. And so you can make backups that go to S3. The file system, this would be a managed file system. So Amazon has 2 flavors, Amazon EFS, which is a managed NFS or network file system, storage system. I use it quite a bit and I'm a huge fan of it, but you also need to make sure that you have the ability to back this up. We also have Amazon FSx, which is NetApp based storage for Windows file server that is managed by Amazon. And then you have object-based storage. This would be Amazon S3 or Amazon S3 Glacier. And then you also have data transfer. So you have AWS Direct Connect, AWS Data Sync, AWS Storage Gateway, and then AWS Snowball. These are all options for hooking up into a backup system. So one of the best practices for S3 cross-region replication is that you make a storage class that replicates the data across availability zones within a different region. Just as a recap again, an availability zone is a physically isolated portion of a region. It typically is more than one data center that's included in an availability zone, and there's typically 3+ on average availability zones in a particular region. So you could replicate across those multiple availability zones. You could also configure S3 cross-region replication for even yet a higher level of data security. So again, if you have requirements where if there was some kind of natural disaster, I don't know, like a typhoon or a tsunami or a hurricane or whatever, you could actually have this synchronized to a totally different part of the world. you can automatically asynchronously replicate objects after you create them. And this is a really cool capability that, before something like AWS really didn't exist. So you're able to add new cloud native workflows, including things like S3 cross region replication. So some of the best practices for EBS, again, Amazon Elastic Block Storage here, would be that you would create a point in time snapshot of EBS volumes. And these snapshots would provide incremental backups that you could actually look at the differences between the last time you did a backup and then make a snapshot change here. The snapshots enable you to restore the data to a new EBS volume. And you can also use the Amazon Data Lifecycle Manager to automate the creation, retention, and deletion of snapshots, right? So if you get too many snapshots, that may add too much cost to your AWS bill. And so it's good to have a plan for how much of a backup you actually want to keep. And you cannot snapshot instant storage, right? So instant storage is really the generic storage where you can't do much with it, but it comes with a machine. Typically, EBS is what people are using for their servers. What about file system replication? So you can replicate EFS or FSX for Windows across regions, and you also can replicate on-premise file systems to the cloud using AWS Direct Connect. And so AWS Data Sync is what you would use. It is a tool that can transfer data sets over DX or the internet, and you can use the service for one-time data migrations or even ongoing workflows for data protection and recovery. You can also use a service called AWS Backup, which manages EBS volume backups and automates the backup of EFS file systems. And you can schedule those backups using Amazon EFS and AWS Backup. The FSX for Windows File Server takes daily automated backups of your file system and enables you to take backups at any point in time. You can also have a daily backup window of 30 minutes. Like most Amazon S3 storage classes replicate across availability zones, you can also do the same thing with Amazon EFS and FSX for Windows File Server file systems. So your disaster recovery could be potentially a multi-region scenario, and you could actually use that capability. Another thing is the compute capacity should be recovered very quickly as well. You should be able to obtain and boot a new server instance or container within minutes. And so a good example of this would be Amazon EC2, would be maybe a custom Amazon machine image or AMI, and you could have this in an EC2 auto scaling group. Another option would be Amazon Elastic Container Service or Amazon ECS. This would be custom container images, and you could maybe provision an ECS cluster and then, instantiate those from images that are stored in ECR. So some of the strategies for compute disaster recovery, this would be using the Amazon EC2 snapshot capability for backup. And these snapshots can be really performed manually, or they can be scheduled. So you could write, let's say, a serverless cloud function with Lambda that could do it. You could also do system or instance level backups infrequently. Typically is a bad idea because you would bake everything in, and you could maybe have fixed a security hole in the past, and then you haven't actually done the latest backup that covers it. It's better to actually automatically rebuild from some kind of configuration or code repo. There's also the ability to do cross-region AMI copies. Again, Amazon Machine Image is something you can customize yourself, cross-region snapshot copies. And you can also build more transient computer architectures. So basically don't store the data on the instance. I would probably lean towards that method. Maybe I would store that data, in fact, on EFS, because EFS, I think, is a great pattern for being able to restore very quickly, because if all the data is in EFS and the machines go away and you don't care about what's on the instance, that actually builds a really good compute disaster recovery strategy. So networking as well is important to design for resilience. Amazon Route 53 is the managed DNS service. You can do things like traffic distribution. You can do failover, including geographic failover. The Amazon Virtual Private Cloud, this extends the on-prem network to the cloud. And the ELB, or elastic load balancing, you could do load balancing, health checks, and failover. And then AWS Direct Connect would be fast, consistent replication and backups of large on-prem environments to the cloud. Databases. So here's some features that are supported in recovery. The Amazon Relational Database Service, or Amazon RDS. This would be giving you the ability to take a snapshot data and save it in a separate region. You could combine the read replicas with a multi-AZ deployment. And also you could do automated backup. So really, this is one of the huge advantages of the Amazon RDS service, is the ability to do snapshots and do like disaster recovery by building multi availability zone deployments and also doing automated backups. You don't want to do this yourself. It's just too much that could go wrong. And by using the RDS service, it handles it for you. DynamoDB, you can also back up the entire table in seconds. It has a point-in-time recovery to continuously back up tables for 35 days. You can initiate backups with a single click. You can also have this concept of a global table that builds a multi-region, multi-master database as well. And this would be fast local performance for massively scaled, globally distributed applications. So there's some really cool things you can do with DynamoDB that most people aren't doing. There also is the automated automation services, so you can quickly redeploy your environment. Because again, if you want to get back into production quickly, how would you do it? Well, you could use things like CloudFormation, which is a template that can quickly just deploy a collection of resources as needed and duplicate a production environment in a new region or VPC in minutes. There's also Beanstalk. You could just click a button, redeploy your stack. OpsWorks, something I've used for years and years in multiple companies. It's a chef-based system where you write recipes and you deploy a whole stack into the cloud. It could be a good solution. So in general, it's important to define your disaster recovery strategy. Okay, let's talk about disaster recovery patterns here. Here's some common patterns on AWS. Would be backup and restore, would be one, pilot light, warm standby, and multi-site. Each one has a different recovery point objective and recovery time objective and cost effectiveness. So these are definitely things to be aware of. And if you are interviewing for a job, for example, it would be fair play to ask someone about recovery point objective, recovery time objective, and cost effectiveness, and even the different kinds of strategies. So here we go with backup and restore pattern. You would have a backup configuration and state data that goes to S3. You would implement lifecycle policy to save on cost. You would then restore when needed. So this is really the concept of backup and restore. So the configuration and the state is in S3, and the lifecycle policy will move that through and go to Amazon S3 standard and then to Glacier, and you only restore it when you're needed. There's also AWS Storage Gateway, which is a pretty cool device actually, where you would hook this up into your on-premise server and you would hook up into the rest of AWS, and it really serves as the storage gateway. And so you could do a backup and restore by having a backup of your current system. You would store the backups in S3. You could document the process, right? Have like a playbook, and then you would know which EMI to use and build as needed, how to restore the system for backups, how to route the traffic to the new system, how to configure the deployment. If there was, that would be prep phase. In the case of a true disaster, you would go through and retrieve the backups from S3, restore the required infrastructure. So the EC2 instances would have maybe some AMIs that are pre-built out, set up load balancing, AWS resources like CloudFormation stack, restore the system for backup, and then route the new traffic to the new system. So believe it or not, I've actually done exactly this before under an emergency, working at a startup in the Bay Area on AWS. And believe it or not, we actually got most of our system back in one day from zero. But it is non-trivial if you don't have really documented procedures. It's a lot scarier to restore an entire company from scratch if you don't have all the automation set up. There's another pattern, which is the pilot light pattern. And so there's a preparation phase with this. And the concept is that it's a disaster recovery pattern where a minimal backup version of your environment is always running, just like a pilot light on basically your water heater. The pilot light analogy is like a small flame is always on, even when the heater is off. And so the pilot light scenario is similar to backup and restore, but the recovery time is way faster because you already have some of the pieces already there. And so the infrastructure elements for the pilot light typically include your database server. This is a critical part of the system, the pilot light. All the other pieces can be provisioned very quickly, and you would provision the rest of the infrastructure around it. The pattern is also really inexpensive because you're only changing the data, and then you can less frequently, maybe verify the compute parts of your environment. So I really like this pattern. I think it's a very interesting pattern where you take the mission critical database and you mirror it, and then you have the ability to spin up the servers, but they're not running. And so if there is a disaster recovery, you just route the Route 53 over there. So what is the checklist for a pilot light pattern? Automatically bring up resources around the replicated core data set, scale the system as needed to handle current production traffic, and then switch over to a new system. So basically have the DNS go there. So preparation phase would be to configure the EC2 instances to replicate or mirror servers, make sure that all the supporting software are available on AWS, and then create and maintain AMIs of the key servers, right? Because if it's the AMI is already pre-baked out, it'll be much faster to restore than to install a bunch of software. And you also want to regularly do a test to make sure that actually it works. Otherwise, you wasted your time. Also consider automating the provisioning of all the resources using, let's say, infrastructure as code. Amazon CDK would be a good example. There also is a warm standby pattern, and this is like a pilot light, but even more resources are running. It further decreases the recovery time because some parts of the system are always running. So maybe you have like a very low capacity web server, a very low capacity app server, but it's set up with an auto scale group. And maybe you have either an on-prem or AWS cloud. Whenever there's a problem with your system, the low capacity starts to scale up, right? And then you switch over the Route 53. In the case of a disaster, the system is able to handle all the production load. The preparation would be similar to pilot light, but all the necessary components are always there, but they're not scaled all up. The best practice would be continuously test this environment, maybe set a subset of the data and do it that way. There also is a fourth and final one, which is a multi-site pattern. And in this approach, you have a fully functional system that runs in a second region at the same time. This would be an active configuration. The data replication method is determined by the recovery point objective. Because both sites can support the full production capacity, you might choose to use a DNS service that supports weighted routing, for example, Route 53. So this would be for environments that just really can't go down. What you could do is you could actually have traffic going to both environments. And that way, if there was an outage, you have an entire replica that can handle all of this. This is obviously much more expensive, but you could get around it by doing things like purchasing EC2 reserved instances, which can save a lot on cost. The checklist would be immediately failover production load. They're similar to standby, but it's already built out for you. So the summary of the patterns would be that there's trade-offs between backup and restore, which is lower priority use case. Pilot light meets lower RTO and RPO requirements. The warm standby is business critical services. Multi-site would be auto failover for an environment to make it a running duplicate. What are some of the things to do for disaster recovery? Well, first is start simple. Making a comprehensive plan can be complex. And so you want to start very simple, create backups, make sure that critical servers are identified, make sure software licensing is solved, and then consistently exercise the solution. So have game day events, ensure that the backups and AMIs are being created and they can restore the data. So that's the key. I've been burned by this before. Is I've checked, made sure we had backups, but in fact, they're backing up the wrong thing. And so the restoration didn't restore anything. And so you want to test your response procedure to ensure they're effective and that teams are familiar with this. All right. So that is a really the essence of disaster recovery here. Maybe a couple things to point out is that the key strategies are important to have the ability to define an RPO, recovery point objective, and recovery time objective, and also make sure you can understand the patterns for disaster recovery and how to implement them, and then also be able to think about things like storage gateway, which can hook into an on-prem and basically AWS and put those together. So that's it for the solutions architect material. Really, next week I am going to cover the bridging to certification. So I'll just talk about some of the ideas of how to pass the solutions architect exam and some things to watch out for. And also I'll talk a little bit about some of the white papers. I think that's a great place to test your knowledge, is to make sure that you've read the white papers. If you haven't read the white papers, you can get yourself into trouble. Okay, that's it for today. I will see you all next week.